Hello, this is a little mini series for chapter 1.4, Solving by Substitution. Um, and I wrote down the steps of how to solve it. It's like 7 steps, but it looks like it's quite lengthy, but it's not that bad. But the first step is to make sure by verifying that this is a substitution type problem by making sure the exponent on the first term doubles the exponent on the second term. So if you look at this example 1, this number's 2 and this number's 4. 4 doubles 2, is twice as much. And on this example, this exponent is technically 1 and this exponent is 2. So these are solving by substitution. These are what we call quadratic form type equations. So they're in quadratic form. They're not really the ax squared plus bx plus c that you're used to, but it's in that form. So whenever the first term doubles the second exponent, it is a substitution type problem because it's quadratic form. So what we're going to do is we're going to reduce it down to the ax squared plus bx plus c form, and because that's when we're more comfortable in solving. So that's the first thing you do is you verify that is the type of problem you're dealing with. The second step you do is you let delta be the middle term without the coefficient. That's probably the easiest way I can explain it. So what you're going to be doing here on example 1, you're going to let delta be equal to the x squared. Okay, that is the middle term without the -7. -7 is its coefficient. So let delta be x squared. Then delta squared will be the first term without its coefficient. Now, the first term does not have a coefficient, so it's just x to the fourth. Okay? So the third step is now to substitute the delta and the delta squared back into the original equation. So in this particular example, you would say, well, that's actually delta squared because delta squared is x to the fourth. Then you would say, well, that's going to be delta squared minus 7 delta plus 10 equals 0. Now, like we discussed in class, the reason I'm using deltas is not that it's just, that's a symbol that you have to use. That's the one I use because that lets me know that when I solve for delta, I am not finished. Some people choose to use another letter besides the x, and they'll use y. But the problem with that is that when you're using y, it's tempting to stop once you solve for the y. And you're not solving for y in this problem. This problem actually has x's in it, not y's. So the reason I use a kind of a non-standard letter or symbol is that when I am done with the delta, I know to go to the next step. Because once I solve for delta, and that's step number 4 and step 3, and factoring is usually going to work. But when I go to step number 5, I replace the delta with the original expression from my step 2. So what I'm going to do here is I'm going to factor this out. And that's what I was saying a while ago, is that it usually does factor. So they're not going to make you use something like the quadratic formula for the most part. They might throw one of those in there, but that's not very standard in their homework given when they give you the homework out. So it's delta minus 5 times delta minus 2 equals 0. That is the correct factoring of this. And then you solve for delta. So delta equals 5 and delta equals 2. So right now I am done with step number 4. I solve for delta. So this is what I was saying. If you use a standard letter like a y and replace it for the x, then you'll get y equals 5 and y equals 2. And it's human nature to say, oh, this is a letter that I recognize, and you might want to stop there. And so a lot of people just say y equals 5 and y equals 2 if they use that letter. So I'm trying to keep you from making that mistake by using something that's non-standard like a delta. And so delta is 5 and delta is 2. So you got to continue. So you replace the delta with the original expression. Well, the original expression for delta was x squared. So x squared equals 5 and x squared equals 2. And then the next step was to solve that equation. So x squared equals 5 and x squared equals 2. So to take the square root of both sides, it's called the square root property. X is equals to plus or minus the square root of 5, and x equals plus or minus the square root of 2. Now, it says check for extraneous solutions. Now, this one is not going to have any extraneous solutions because it's x to the fourth minus 7x squared plus 10 equals 0. So there's no fractions there, there's no square roots there, so these numbers should be fine with it. The only way I'd made a mistake there is if I made a calculation there, so I'll leave it up to you to make sure I didn't make any of those types of mistakes. So, but x equals plus or minus square root of 5 seems like, and x equals plus or minus the square root of 2. Now this next example is very similar, but it looks totally different. So, but we go through the same way. We're going to verify that it is a substitution type problem. The middle term has 3x plus 1 to the first, and the exponent has 3x plus 1 to the second. So this exponent doubles this exponent. So that's why you know it's a substitution problem. And a lot of people will try to stick in these types of problems right here. They'll probably try to keep from doing the substitution by multiplying this all out. But if you do that, you're going to have a long list of terms that are really long. So you're going to have a lot of terms there. And besides, I'm going to say on the test, probably to solve by substitution. So if you multiply this out, then rearrange the terms, you're not going to get the credit. So you've got to be careful and you solve it by the technique that I asked you to solve it by. So solving by substitution, so we have verified that this doubles this one. And if you notice, 3x plus 1 and 3x plus 1, okay? So that's kind of a dead giveaway that they're trying to trick you anyway. I mean, this one's 3x plus 1, this one's 3x plus 1, and if you're trying to multiply it out, that should be a little red flag that shows up there. So, I mean, you're like, well, how would you want to multiply that? Well, if this was a 3x plus 1, this was a 2x minus 3 or something like that, then yeah, you can't use substitution because they're not the same thing. So there you do it. But when these are the same, that's the things that you should look for appearances for that. So what I'm going to do is I'm going to let delta be equal to 3x plus 1, and I'm going to let delta squared be equal to 3x plus 1 squared. So delta is the middle term without its coefficient, and delta squared is the first term without its coefficient. So replace those, so you get 2, and 3x plus 1 squared is delta squared, minus 5 delta minus 3 equals 0. So, and at this point you solve for delta, and hopefully it will factor, and most of the time they do. So it'll be 2 delta times delta, and I believe the choices would be a 3 here and a 1 there. And that's 2 delta times 3 is 6 delta, and that's 1 delta. So the combination subtracting gives you 5 delta. But I need it to be a negative 5 delta, so it's going to be a negative 6 and then a plus 1. So in this case, delta is a negative 1/2. Subtract 1 and divide by 2. And in this case, delta equals 3. And again, this is the reason I use delta, is because if I was using y's instead of deltas, it would be tempting, because you've done like 4 steps. It's tempting to say this is done, but it's not. Delta is negative 1/2. Not solving for delta, not solving for y. I'm actually solving for x. So you have to put 3x plus 1 back in for the delta. And on this one, it's not so bad. You just subtract 1 from 3 and get 3x equals 2. And then divide by 3, and x is 2/3. So 2/3 is one of the answers. Now on this one, you might want to go ahead and multiply by 2 to get rid of the fraction. I'm going to do a little bit of cheating here. I'm going to do 3x and subtract 1 from a negative 1/2. You get negative 3/2. Okay, and if you multiply both sides by negative just 1/3, it'll cancel these 3's out right here. So x equals, and then negative 3/2 times 1/3 is actually negative 1/2. So, and so x is a negative 1/2, which is coincidental that the delta was negative 1/2. It just happens to work out that way. So x is a negative 1/2, and x is equals to 2/3. And this is, again, check for extraneous ones, and there's no square roots or no fractions involved, so there is no chance of having extraneous solutions. So, but again, this problem right here is probably the most commonly missed problem, because people will try to multiply it out. So you got to be careful and look for those substitution type problems, and that's why I put the first step in there, to look for those. So if this is if anything, if the first term is half of the exponent of the second term, then that's how you know you got a quadratic form. Therefore, use substitution type problem. So part 2 is coming up. All part 2 is going to be is just a couple more examples of this. So with a little bit different flavor of equations. So that concludes part 1.